Welcome to the course on FPGA based signal processing systems. So, we will continue with this timing controls, which have been classified as three types: the delay based timing control, event based timing control, and level sensitive timing control. We had seen in the previous lecture what are the three different types of delay based timing control: regular one, intra assignment, and zero delay control. So, in this lecture we will be focusing on the event based timing control, whereas this is also classified as regular event, named event, and event OR. So, in this that is an event change, it can occur in the register or a net. Okay. The value of that will be stored based on that event. So, when we say event, it is triggered by some signal, or it can trigger the statements or the block of statements to be executed. So, the event can be used to trigger these statements or block of statements. So, the regular event control, which is named based or event OR. So, there are three types in this event based only. Usually the @ symbol is used to specify this event control. So, whereas in the case of delay based, we have used this hashtag, right. So, here is @ we are using this in sequential with always block. So, if you remember, so the @ symbol specifies the event. It changes the value either at the passage of the clock or negage of the clock, that is, the clock is the signal value where the transition is occurring. So, the all with @ or now classified under event based. In that, regular event or named event or event OR control is also there. So, @ for example, here clock q equal to d. Clock is here this, whenever the clock is 1, that is the @ changes, d will be assigned to q. Okay. Signal clock value changes, d is assigned to q equal to 1. So, always @ passage of the clock, q is d. So, it is looking for the clock to have the passage. Okay. So, when there is a passage, this we are using in all our state machines and sequential logic circuits. This is, you can notice the one which is @ that is the event base. This is the event which is specified in the statement. When we say passage of the clock, the thing to be noted is it is from 0 to 1 transition or 0 to x transition, that is unknown or do not care, or 0 to z transmission, the high impedance state. So, the transition is from 0 to 1, 0 to x, or 0 to z, named as x to 1 also, z to 1, all of this considered to be passage of the clock. 0 to 1, x to 1, z to 1, okay, or 0 to x or 0 to z, all of this are considered to be positive transition. So, negative transition has a negage from 1 to 0. Similarly, this is the negage of the clock. When we say @ q is d, d will be assigned to q. 1 to 0 is also negage transmission, 1 to x or 1 to z. So, these are all negage transmission, or x to 0 or z to 0, all of them are considered to be negative transitions. Q @ passage of the clock, d is here evaluated immediately. Again, we can say that is that evaluation immediate or not. So, d is evaluated immediately. At passage of the clock, d is assigned to q. So, that the difference can be observed here. So, q is negage of the clock, d is evaluated and assigned to q here. So, you can see that q is at the left hand side here, q equal to @ passage of the clock, d. D is evaluated immediately and then assigned to q at the passage of the clock. So, here evaluation is negative edge, evaluation is at passage. So, the next one, that is a regular one, named event. So, we can name the event and use this event to trigger the next any of the statement or the variables, variable assigning or evaluation as well. So, it is declared as event. Okay. So, to recognize this event, let us see some data packet receiving and then assigning it. So, that is named as event receive data. So, this is to receive data is a variable which is declared as event, and then always at passage of the clock check for something. Here the conditions begin if this last data packet is true, or if this is the last data packet, then trigger an event here. This is going to be an arrow mark dash with greater than symbol received data. So this is to be specified to trigger that received data event, which is specified in the specified over here. Event received data, then dash greater than or equal to received data. End. Okay, so the initial begin with the end. So always at the rate receive data, when the received data is true, that is here buffer is assigned some values D0, D1, D2, D3 of values can be concatenated and assigned. So this is this is the example of the event based control. In that event based, the named event should be given as event and then name that event, what is the event, and then use this received data wherever we want to trigger trigger this received data after with the condition if that is going to be a last packet, received data can be triggered. Then once this received data is triggered, then check whether it is always at the received data, it's true, store the data here. So this is a named event, example of a named event. The third one, the event OR control. This we use again very much. The at the rate, similar to the at the rate one. So this transition of any one of the multiple signals can trigger the execution of a statement or the block of statements. So you use this uses the OR as an event. Let's look at the example of this OR event. For example, in the sensitivity list of an always block, always at the rate AR. In the previous examples in the state machine also, enable OR SRIG, enable OR passage of the clock. If we have more on the sensitivity list, so we are writing OR R, that signifies this event OR. So that is a sensitivity list. The keyword used is OR here in the event based OR control. Okay, so look at the example. Always at the rate reset or clock or D. Okay, or this can be replaced with this R can be just replaced with a comma. We can use a comma operator as well, which is meaning the same. Begin, if reset true, Q equal to 0, assign Q 0. Otherwise, if clock is true, then D assign D to Q end. So either we can use this OR event control as specifying OR the signals, or it can be comma operator also will work a similar fashion. So then event controls mainly uses at the rate 1 and or in the sensitivity list are naming the event, like event received data, and then trigger that with the arrow. Those are the three types of, so the sensitivity list which can have the, in this case, R or comma. So this is an example. So how many signals can be listed in the sensitivity list? If a combinational circuit which has more number of inputs, then to list all of them, it will be difficult one. So list, suppose 10 variables are there, so the sensitivity list will be more and more cumbersome to write all of the variables inside that. So instead of that, we can use at the rate asterisk, or at the rate, instead of listing all of the variables within the bracket asterisk. So this is sensitive to all the input signals. That means you need not give it in the sensitivity list all the variables which are on the input. It automatically takes from the input declaration what are the signals are to be considered here. That means all input signals will, whenever there is a change, this would be executed. So for example, always at the rate A, B or C or D, E, F, G, H, so many variables here. So instead of that, we can write always at the rate within the bracket asterisk, and then do the coding, whatever out one is A ternary operator, B and C is true, or D. So which one should be? A is true, then B plus C assigned to out one, or A is not true, D plus E to out one. That's a ternary of out 2. Similarly, if F is true, then G plus H is assigned to out 2, or P plus M can be assigned to out 2. So this requires all these inputs. So instead of listing all of them in the sensitivity list, we can just give this at the rate asterisk. the here end. So this is an event or control. So at the rate or event or control are the which can be used with comma as well. The third one is this event, specifying the name of the event also in the within the code to trigger that event later in the part of the code. So the third category of timing controls, that is delay based, event based. So the delay based, we had this hashtag, and the one which is regular delay control, also hashtag, and how we use intra assignment, okay, 0 delay. We use the delay based. And in the case of event based, again those three types. The level sensitive timing control, which is the third category of the timing controls, we are using this level sensitive in the latches. So along with the level sensitive, the wait statement is used. The wait is a keyword here, that whether that wait for some time and then execute a particular statement which is going to be true, or block of statement as well. So the keyword is wait, used in the level sensitive along with this level sensitive constructs. Let's see the example here. Always wait for some time, enable, this enable is being true, wait for it when enable is true, and then hash 20 count equal to count plus 1. So when enable is 1, after that see the wait for 20 time units and increase this count to count plus 1. The enable wait with the wait statement, enable is continuously monitored here, and if enable is 0, the statement is not entered into this. Actually, this is wait. Like always at the rate, we are looking for passage of the clock. Similarly, in the level sensitive, wait till that enable becomes true. If it is logic 1, then this count equal to count 1 will be executed after 20 time units. Okay, so till that enable is 1. If enable is 1, every 20 time units count will be increased. If enable is 0, it won't be. It is staying at the same state. So count will be incremented every 20 time units. So with this we have these different types of timing controls which are used in the Verilog constructs. We'll see this procedural assignments then as these procedural assignments carry these timing controls always in the Verilog codes modules, and see what are the types in which these assignments are done. So the procedural assignment, it is evaluation. Based on the evaluation, how this procedural assignment are getting evaluated, it can be modeled as the following. So blocking or non-blocking, so which we were using in all the examples, blocking and non-blocking, the equal to sign, and the non-blocking is the less than or equal to. So here the assignment is based on this evaluation. Now coming to the procedural assignment, it can be again categorized with respect to the execution. Okay, can be modeled. What are the ways in which? Again, it is a sequential execution or concurrent execution. So that is, the statements are executed, should be executed sequentially. For example, within the always block, it should be sequential, or concurrent statements, like in the primitive gates instantiation, or 2 always blocks or 2 initial blocks. So those things are concurrent. So this should be executed sequentially or concurrently. So these are the categories. And the procedural assignment also, timing controls, based on the timing control, we can model them as follows. That is delayed evaluations. So the evaluation is delayed, like the regular delay control, and then delayed assignment. If the assignment is delayed in the intra assignment delay, so the delayed evaluated and then assigned later. This is evaluation itself is delayed and then assigned quickly. So these are the examples of the procedural assignments of the timing control. So these 6 categories of procedural assignments, with a combination of this, suppose for blocking, delayed evaluation, blocking, delayed assignment, non-blocking, concurrent, or non-blocking, sequential. This can be combined in any fashion. So the 6 of them can be having this 1 or 2 or blocking assignment, that should be in sequential, or non-blocking assignments with sequential, or the concurrent with blocking or non-blocking, and so on. So this 6 category is understood, then it will give more clarity on the Verilog constructs the module which you develop there. So, if taking the examples of blocking, we've been already using, and few examples have been taught in the some few lectures. So, the equal to sign, it's representing the procedural assignment of blocking. It evaluates and assigned in a single single step. There is no storage like in the other case. So, while we are calling that as blocking, it is evaluated and assigned immediately. Until this assignment, the execution flow, the next statement will not be considered in the execution. So, this is called blocking because of the because of next statement is getting blocked from the execution until it finishes this assignment. So, that is why it is a blocking procedural assignment. And then in the also evaluation of concurrent statement, if we say take it concurrent and the same time step, these are blocked until the assignment is complete. Okay, so if you use this in the concurrent assignment also, or the concurrent statements, so it blocks the next one before assigning that, the next statement will not be executed. So, it is just called blocking because of the immediate assignment, and then it blocks the next statement execution. So, the blocking and the non-blocking, we say this non-blocking here, it is going to be less than or equal to, in which it is evaluated and assigned in 2 steps. So, for example, the right hand side is evaluated immediately, but this one assignment of the left hand side is postponed until the other evaluations in the current time step are completed. So, we have seen this, if you have 2 non-blocking statements, all of them, these 2 of them evaluated, but assigned at the left hand side at the current time step. So, the difference we had seen with the swapping examples and the shift register example also, the less than or equal to representing the non-blocking assignment. It is done in 2 steps, evaluate and assign later, but in the blocking one, evaluate and assign in single step. So, the execution flow, why we say this is non-blocking, it is continuing the next statement evaluation. It does not block the evaluation or execution of the next statement. In that, the flow is not blocked, that is why it is called the non-blocking. It looks for the next timing control and proceed before the assignment. So, the sequential procedural assignments. So, the first 2 and blocking and non-blocking procedural assignments we had seen, and examples also we have already done, and we will be doing it for with the simulator. Sequential procedural assignments, we know the within the always block, it is the procedural assignments are executed, that is sequential. So, the order of evaluation is determinate, that is, it is deterministic, there is no confusion in the order in which it is getting executed. The sequential blocking assignments evaluates and assigns before continuing in the procedure. So, we have multiple procedural assignments, evaluate, assign, evaluate, that is a sequentially done every statement. For example, always at the passage of the clock, begin a equal to 1. So, this is blocking statement. A is assigned 1 at time t equal to 0. This is evaluate and assigned immediately. So, after 5 time units, this A is whatever A, because it is an immediate assignment, this would have been 1 already 1. So, it is going to be 2 and B will be getting 2 at 5. So, delay 5 time units, then evaluate and then assign. So, immediately at 5. So, it is evaluated and assigned. So, but this execution is sequential. Okay, so this is blocking and you have the timing control, and this is inside the always block, begin end. So, it having the sequential procedural assignments with the timing control. The order of execution is determinate. So, whereas in case of non-blocking assignments, if you see always at the rate passage of the clock. So, if we make this non-blocking, what happens is still it will be getting this hash 5. So, because there is no time, it is evaluated, it is not assigned immediately and looks for this, I mean it goes to the evaluation of A equal to 1, but at current time step, the t equal to 0, at the end of the time step, this A gets 1. Because it is having, next statement is having the delay of 5, A is A1, is A plus 1 is assigned, evaluated and assigned after 5 time units. So at the end of clock 5, B is getting the 2 value, 2 value, that is at end of the 5. So year 1 is, A is getting 1 at the end of current time step 0 end. Okay. So if you look at this passage of the clock and do it, then you can see that at the end of time step this is getting 1, whereas this is getting 2 after 5 time units. So evaluate A immediately, assign for at the end of current time step compared to the blocking one, but the order, this is non-blocking, the sequential non-blocking assignments, no, it is taking the taking the timing controls as a, because this is evaluated and assigned. If you have something here without hash 5, this is evaluated but not assigned at the same to B. So both of them will be getting this A and B at the end of the time step. So because of hash 5, it moves to the next hash 5 time in the non-blocking and evaluates, and then at the end of 5 it is assigned here, end of clock plus 5 statement. So that is about the sequential procedural assignments. You can have this concurrent procedural assignment, that is execution in sequential is deterministic. The concurrent procedural assignments in which the order of evaluation is indeterminate. So if we have multiple always block or 2 always block, see that concurrent blocking assignments have unpredictable results. That's why, so we have that the previous one, we have determinate and the results are predictable, whereas we have this example, for example, that in indeterminate the concurrent evaluation and unpredictable results. This care has to be taken when we code this concurrent assignments, always at the rate passage of the clock. Hash 5 A equal to A plus 1. Okay. So delayed evaluation, this is a blocking assignment, whatever A value was there, so that is A equal to A will be updated hash after 5 time units. Always at the rate passage of the clock, the other one, use this A plus 1 hash 5 B equal to A plus 1. Okay. So it is assigned here. So with this A value, this value, because this is also hash 5, so we will take either, I can see the unpredictable result here, the new value of B, which is over here, whether it is taking the old value of A or the new value of A. So there will be a indeterminate unpredictable result over here. Okay, because this is of the immediate assignment. At 5, this is getting the value A and this B also getting this value. So before that it needs to evaluate it. So at the same time it is evaluating. So it would take the A value which is assigned, or it would be going to be assigned. So there is a unpredictable result when we use the concurrent evaluation. Okay. So concurrent 2 always block here, but before it can be, B can be evaluated before after A changes. So it is unpredictable in this case, because of this immediate assignment. So if you make it non-blocking, yes, this would be taking definitely not assigned at that time current step. So it will take the old value and calculate it and wait for the assignment at the current 5 time units for assigning. So if you use the blocking statement with concurrent evaluation, yes, this would be a unpredictable result, indeterminate one. So concurrent non-blocking assignments have predictable results, always at the rate passage of the clock. The same code, we change it to non-blocking statement, hash 5A less than or equal to A plus 1. So hash 5B less than or equal to A plus 1. So definitely it is not assigned, hash 5 is evaluated, not assigned. So this is evaluated, so the old value of A, whatever is there, it's evaluated, and as B is getting that at the same time at the end of the current time step, and A is also getting at the end of the current time step. So A and B will be updated with the new values at the end of current time step, that is 5. So the solution would be here, to have the predictable result, make it concurrent non-blocking, concurrent statements with the non-blocking assignments. So it gives the predictable result, new value of B will always be evaluated before A changes here. Okay. So now the delayed evaluation of the procedural assignments, in which, so he have this case, the timing control before an assignment statement will postpone when the next assignment is evaluated. Okay. So evaluation is delayed for the amount of time to be a specified time in this delayed evaluation. So for example, delayed evaluation or delayed assignment in the procedural assignments. So delayed evaluation, you can say this, suppose it is here hash 5 A equal to 1. Delay for 5 time units and A is assigned value 1. This is delayed evaluation. That is, if you have the regular time delay control before the this statement. Hash 5 A equal to A plus 1. So it's wait for another 5 more time units, that is 10, and that what A was there, A suppose 1 plus 1, A, this A will be 2. And if it is sequential, again this would be B will be getting A plus 1, that is 2 plus 1 3 at the end of the after this execution, it would be getting this, because it's going to be a sequential execution. A will be getting after 10 what was there to be to the 2, and B will be getting that value. So it is no delay, evaluate and assign, but after 10, because it is getting, it is sequential, so it will be B will be evaluated after this. So this is the delayed evaluations. So you can take these examples for the delayed evaluations. So whatever the time specified, the evaluation itself is delayed and then assigned here. Delayed assignment, so the intra-assignment delays, that's it plays a time. In this case, it's going to be the example of the delayed assignment is intra-assignment delay. So right hand side of the expression is evaluated. After that time, it will be assigned to the left hand side. So let's see, the left hand side is assigned after the delay. For example, always at the rate A changes, whatever the A changes, hash A will be reflected here, and then it is not assigned to B, it will be taking 5 time units and then assigned to B. So whenever it changes, it is evaluated, it is assigned after 5 time units to B. So that is delayed assignment. So always at negate of the clock. So you can see Q is less than or equal to at the rate passage of the clock D. Okay. So in these cases, D is evaluated at the negative edge of the clock. Okay. So whenever always at the negative of the clock, come to this and evaluate this D, and then at the rate passage of the clock, it is assigned to Q. So Q is changed only at the passage of the clock. So negative edge of the clock, what is D? That is evaluated, and this is the intra-assignment delay at the rate passage of the clock with the event based control at the passage of the clock, then assign this to Q. So D is evaluated and assigned. With this, we have the 6 types of timing control, procedural assignments, and the timing control types, that is 3 timing controls, the delay based, event based and level sensitive timing controls. We had seen the level sensitive we use also in the latches. Whenever there is an enable is true, what is that to be executed, which is using the wait start statement as well. And apart from this timing control, we have the procedural assignments, which can be classified into 6 of them, depends on that evaluation, and then blocking, non-blocking, and then execution of statements, whether it is sequential or concurrent. Okay. And then the assignments, this is the delayed evaluation or the delayed assignment. So based on that, these 6 categories, will combine them and then and see the Verilog constructs how it responds if you combine this blocking and concurrent, or blocking and sequential, and so on. So it would be a little difficult to get into the details of all the 6 combinations. We will be doing it in the next lecture then. Thank you.